Chapter 34 is going to look at the progression of vertebrates, and this is going to start with the early chordates. There are a couple of groups that are actually considered invertebrates. So this is our big phylogenetic tree of all of the deuterostromes. So we've got Echinodermata as our outgroup, so these are obviously invertebrates. And then all from here down are our chordates, and this is going to include all of our vertebrates and includes you. So the first two groups we have up here are the Cephalochordata and the Urochordata. So those are chordates because they have the four characteristics of chordates, including the notochord, but they're not vertebrates. We actually see a vertebrae get developed right here, and so from here down, all of these organisms are going to be vertebrates. So you're going to see the vertebrates are going to create this kind of nesting of groups. So we're going to keep going down this tree as we go through these groups. So this first group up here are the Cyclostomata, and these are technically vertebrates, even though the Myxini, the hagfish, don't actually have vertebrae. So the Petromyzontida, they do have vertebrae, but they're really, really small. And there's new genetic evidence that Myxini did have vertebrae and then actually lost them. So this is technically an invertebrate, but it's not because it never had vertebrae. So we actually group these together into a group called cyclostomes. So this means circle mouth because these don't actually have a true jaw. The sister group to this is going to be the gnathostomes. So the G is silent, gnathostomes. So from here down, everything from here down is going to have a true jaw, top, bottom, closing jaw, as well as a mineralized skeleton. So this means that it's got a bone skeleton. And this we actually think is the ancestral form. So the first group off of this is the chondriichthyes, so these are the sharks. And these are going to have a cartilage skeleton, and that's actually a new feature here that they gained after having a mineralized skeletal ancestor. Down from there, we have the osteichthyes. So oste means bone, ichthyes means fish. So everything from here down, yes, including you, is a bony fish. And they are going to have lungs or lung derivatives. And so by lung derivatives, we're talking about things like swim bladders in fish. And so we actually think that lungs developed first, and then the lung derivatives, the swim bladders, developed as a result of lungs. So the Actinopterygii here are going to be our ray-finned fishes. So these are most of the fish that you're going to be familiar with. And then our sister group to that is going to be the lobed fin fishes, which is called the Sarcopterygii. So these are going to have fish fins that have a bone in the middle with muscles surrounding it. Sounds kind of like a limb. So it's not quite a limb yet, it's still a fin. We have a couple of grouped of those, the coelacanths here, the lungfish, and then the tetrapods. So tetra meaning four, so 4 feet. So everything from here down is going to technically have 4 limbs, or have an ancestor who had 4 limbs. And these limbs, so these 4 limbs, are going to have digits. So these are fingers. We have the amphibia, who are going to have to live very close to the water. They actually lay their eggs in the water to make sure that they don't get dried out. And then we get the invention of the amniotic egg. And so that's going to create this group here called the amniotes. And so these are going to be eggs that either have a shell, like they do in reptiles and birds, or get retained inside of a uterus. So that's in mammals. You actually have an amniotic egg, you just don't lay it with a shell. And then the last grouping here are the mammals, and some characteristics of mammals are going to be the invention of mammary glands and milk, as well as hair.